In this video, we are going to see about the 7-step procedure for designing a Chebyshev filter. In our next video, we will see how to design a Chebyshev filter. This is a type 1 analog Chebyshev filter. So, in step 1, what we are going to do is we are going to draw the frequency response graph from the given specifications. So we will have the x-axis and y-axis. X-axis is omega radian per second and y-axis is mod of h of j omega. We will have 4 parameters here. So the first one is AP, which is passband gain, and AS, which is stopband gain. Alpha P is the passband attenuation and alpha S is the stopband attenuation. So after we drawn the frequency response graph, we will go to the step 2. In step 2, what we are going to do is to find the order of the filter, which is denoted by n. We will find the order of the n using a formula which is given by n is greater than or equal to cos h inverse lambda by epsilon divided by cos h inverse omega s divided by omega p, where lambda and epsilon are attenuation constants, and lambda is equal to square root of 10 to the power 0.1 alpha s minus 1, and epsilon is equal to 10 to the power 0.1 alpha p minus 1. If the specifications are given in the terms of gain AP and AS, then lambda is equal to square root of 1 divided by AS to the whole square minus 1, and epsilon is equal to square root of 1 divided by AP to the whole square minus 1, where omega s and omega p are stop band and pass band frequency respectively. Now we are going to step 3, in which we will round off the value of n. It is also called seal off. So if we get the value of n, say if n is greater than or equal to 3.38, then the value of n we will assume it as 4. So finally the order of the filter is 4. Now we are going to the step 4. In this step, what we are going to do is we will find the minor and major axis of the ellipse. Formula for this: the minor axis, which is denoted by A, is equal to omega p mu to the power 1 by n minus mu to the power minus 1 by n divided by 2. The major axis, which is denoted by B, is equal to omega p mu to the power 1 by n plus mu to the power minus 1 by n divided by 2, where the mu is given by epsilon inverse plus square root of epsilon to the power minus 2 plus 1, and epsilon is equal to 10 to the power 0.1 alpha p minus 1, which we already know. So we move on to the step 5. In this step we will find the poles of the filter, which is denoted by pk. So the p suffix k is equal to a cos phi k plus j b sin 5k, where k ranges from 1 to n, where 5k is equal to pi by 2 plus 2k minus 1 divided by 2n into pi, where k ranges from 1 to n. Now we move on to the step 6. In this step we will find the denominator of the transfer function of the filter. So the denominator of HA of S is equal to 1 divided by S minus P1 into S minus P2 to S minus Pk, where the number of poles is equal to the order of the filter. Now we move on to the step 7. In this step we will find the numerator of the HA of S, which is a transfer function of the filter. So if the order of the filter value of S is equal to 0 in the denominator of HA of S, and the value what we are get is the numerator of HA of S. Whereas if n is equal to even, substitute the value of S is equal to 0 in the denominator, and the value which is divided by the square root of 1 plus epsilon square will be the value of the numerator of the transfer function.